Okay, so this is how to make a cell equation. If you get a question on electrochemistry, they're going to ask you how to make a cell equation. So what I've got here is two half cell equations with their electrode potential values at the end there. So I've got a potassium one and an iron one. And I've just written down at the bottom, the most important thing to remember, the more negative electrode potential is oxidized. So if these were your two half cell equations and you were asked to combine them, here's what you do. Step one, figure out which of the equations is being oxidized and which is being reduced. And the more negative is the one being oxidized. So what you can do is get your hands, your little finger, little index fingers, put your right hand on the more negative electrode potential, and put your left hand on the more positive electrode potential. And that'll tell you which way they're going. The more negative is going backwards, look at the direction of my finger. The more positive electrode potential is the equation going forwards. So I'm going to write those out going the correct way. So my top equation is going backwards, so the reverse equation is potassium goes to K plus and an electron. My more positive electrode potential, left hand, is going forwards, so that's Fe2 plus 2 electrons goes to Fe. What we now have to do, step 2, is balance the electrons. So you can see there's 2 electrons in this bottom equation, but only 1 in the top, so I need to balance that by multiplying everything in that top equation by 2. Now we can combine the equations, so everything that's a reactant, so on the left-hand side of both of these I'm going to write down, so that's 2 potassiums, add an iron, add the 2 electrons, and then everything that's a product from both the equations I'll write down on this side. So 2 potassiums, 2 electrons, and an iron. Step 3, the final step, we cancel out anything that's the same on both sides. Now, if you've balanced your electrons in step 2 correctly, your electrons should always cancel out. If your electrons don't cancel out, you haven't balanced your electrons correctly. So go back and do it again. It may be the case that other things can cancel. Maybe you'll have some H pluses on both sides or some waters on both sides. If that's the case, cancel them as well. And then all I'm going to do is just rewrite it nice and neat for the examiner, because we want to suck up to them and make their job easy. So that would be my overall equation. I'm going to put another one up and I'm going to ask you to stop the video, have a crack at it yourself, and then I'll quickly whip through the answer. So pause the video now. Hello, welcome back. So what have we got? We have our more negative electrode potential is the top one, which isn't always the case, and our more positive electrode potential is the bottom one, so they're going to go like that. So let's write that out then. Mg goes to Mg2 plus 2 electrons, and then Al3 plus 3 electrons goes to Al. Step 2, balance the electrons. Well, I've got 2 electrons here and 3 there, so I'm going to need to multiply the top by 3, so 3, and that will now be plus 6 electrons. And I need to multiply the bottom by 2. So 2, that will now be 6 electrons and 2. I can then combine them, so all my reactants are going to go here. And all my products are going to go here. Now when you get good at this, you don't need to write out the electrons because you know they're always going to cancel. So I really don't usually write out the electrons because they're just going to cancel out. And that will give us our final equation, nice and neat for the examiner. like so. One really nice way to check you haven't messed up somewhere is to see if your charges are the same on both sides. You should always have the same charge on both sides. So 2 times 3 plus is plus 6, 3 times 2 plus is plus 6. Looks good to me.